No idea. We'll try this again. Oh, okay. We got sound now. Okay. Well, hopefully that's working then. Okay, welcome to Programming Rainbow. I'm not doing any specific tutorial right now. I am just working on something that I've been working on and I haven't streamed in a long time because we moved. So you can join me. Hopefully, if this is working, it's just kind of a test. And right now, I've been working on how to kind of like a couple different things. I was wondering if you could just like make a game in Bash or Shell. It doesn't need to be specifically Bash, but I'm using Bash. Um, to make like a 2D game or something. Why couldn't you do that? It's not technically a binding because there is no way to bind, but it is like a bridge or something or a client server type deal. So then I went down this rabbit hole of how fast can you send information from Bash to a C server and back again, like a round trip. Because the issue that I have going on here is it's not Bash is slow because Bash is for what I'm trying to do here fast enough. But sending information from basically I'm going to start up a server that is running SDL as a C program, and then Bash is sending it messages and receiving. So it looks like binding in Bash, but it's actually not because Bash isn't actually doing any of the memory management. But it's not really important. It kind of looks like something you would do in another language where you'd have a binding. But really, what you need to do is just talk from Bash as the client to the C program running as a server. But he also needs to reply back again because all the logic of whatever game you're making is actually happening in Bash. But to draw things and display things on the screen, it's happening in C. So hopefully the stream is working. Let me just test it again. I have no idea what's going on here.
But to draw things.
Okay. And yeah, like this again, this is just a test stream, so if I mess it up, it's not a big deal. So this interprocess communication is kind of this little rabbit hole I went down, trying to get maximum kind of speed out of this. So I did put this up on my GitHub. So if anybody else is wondering about how to communicate from Bash to C as fast as possible, I'm not an expert at this, but this might be a starting point for somebody else, or if somebody knows more than me, they could always contribute and let me know if there is an even faster way. So I made this little test program that sends a number to a small C server, and then receives that number back, and then checks that number to make sure it's the correct number, and then increments itself. And it does this 1 million times, and I did it 4 different ways. So if you were to ask like ChatGPT how to do this, they would tell you that the very fastest way to send and receive information, even using from Bash, it would recommend using a small client program. So you have a C server and you have Bash spinning up a small client program that is then, it says, should connect with a shared using shared memory. So basically, the small client that you just spun up and the server are mapping the same memory, so they can just use the same memory. So how fast is that? Well, if I wanted to send and receive 1 million times, it takes about 15 minutes on my system, and I'm using the AMD AI9 HX370, whatever it's called. And so that's when I plugged in, it can do it that fast. So I'll just show you real quickly. I'm not going to show you the slowest method. Yeah. So this is it. So what I got going on here is I have this little server, and I tried to leave a bunch of comments for anybody else who is kind of going down the same thing, wondering the same thing. So I do have lots of comments here, but what I've done here is this little this little mini server just for finding out how fast I can communicate has 3 different implementations built in. One is a shared memory, the other one is a named pipe, and then a Unix socket. So shared memory should be the fastest. then it should be a pipe and then a socket. But if you were to ask how to talk from bash to the C server with shared memory, it would recommend using a client. So here is my little client. And so this little client spins up and it connects. This client is specifically only for shared memory. It maps the shared memory. And what I have going on here is I have two different right here. I'm basically making two different ones. One is a data. One what do I want to call it? Shared memory location. I'm not sure exactly what it's called. This dev shim. I'm calling it my shared data and a lock. So what I'm doing here is I have these different kind of I'm using the first bit of the lock to it's either going to be 0, 1, or 2. If it's 0, that means nobody's talking on it. So my client can write to data, and nobody's trying to read. While lock is 0, nobody's reading. There's nothing to be read. So while lock is 0, I'm writing to data from the client. When that data has finished writing and that's done, I switch the lock to 1. Now, when the lock is 1, that means the server can read and write. So the server says, it's my turn. Lock is 1. I'm reading the data. I'm going to process the data. Now I can also write to it. I don't need to wait for anything because the client's doing nothing. The client is not doing anything when it's set to 1. So since the server at 1 can read, when it gets done reading, and it actually, let me show you what it does, because it does a round trip. Sorry, this is not meant to be a thing. I'm just kind of showing off what I've been working on here. But let's see. Into the shared server. So this is the actual tight little loop right here. And this little thing spins, which is not great. The shared memory, I didn't do anything fancy enough to where I have it blocking. That would actually be better if it was blocking, but instead it spins. And the server side, if I were not to let it sleep, I'm using this nano sleep. If I were not to let it sleep, it is almost not faster. It's just marginally faster. However, it uses 100% of the CPU. But if I do let it sleep, it ends up sleeping for about a millisecond, which is a long time, but it causes the CPU to drop down to like 20% or less or something like that. But you can't really slow it down less than that because it doesn't matter if I tell the number to be smaller, it's still going to be about a millisecond because of the way it works. But basically, it just keeps checking the lock. Once the lock is 1, it's going to be, this is the server side, yeah. So, sorry, this is the. Oh yeah, sorry. I'm looking at the 0 here. I'm spacing out. This is the lock, and I'm only care about the first character of this lock, which is actually is a character, but I'm using it as a number. If it is 1, that means it's my turn to read. So I read the data, turn it into an int, and I'm not really doing any error checking here because this is just for me to know how fast I can communicate. That's all I really care about. And then once I have that int, I just literally write it back using snprintf back into the same data, and I set the lock to 2. Once the lock is 2, the client says, now it's my turn, and the client reads it, sets the lock back to 0, and also checks that number against what the number should be, which is, but that's just how this specific one works. So this thing is spinning all the time, basically. And the client is also spinning while it's waiting. So it's not amazing. Now this thing, I don't want to run it because to run a million, to send and receive 1 million times takes 15 minutes and 15 seconds on my machine when it's plugged in, which is a laptop. But when it's plugged in, it runs a little bit better. And I'm not running my laptop very hot. I'm running it at like 2 to 10 watts or something like that because it is a laptop. So if I was running a different profile, it would possibly run a little faster, but it's really slow. It's 915 seconds or 15 minutes and 15 seconds is what I timed it at. And this is 100 times slower than than the fast method. So, like I said, I'm not going to show this, but this same server also has a pipe and a socket implementation. So basically, these are the functions in the server. There is a pipe free and a pipe run, a socket free and a socket run, and a shared free and a shared run. So the little client one doesn't need to be run. That's only for clients. You can actually use Bash and connect directly to shared memory with Bash, and it's a little bit goofy. It's not optimal. However, it is much faster because spinning up a little client and then having it connect and then spinning it down over and over again is really slow. So when you do it directly from Bash, even though it's really goofy, and let me just show you how goofy it is. So that shared one so basically I have like 4 different backends. So this client one, I have this little, where is it? Send to server. This is how I do it right here. It's just very small, but on this, that's because there's a little client that's connecting to shared memory. But when I do the shared memory directly, that same function looks like this. This whole thing right here is the same thing, because what's happening is there's no way to, I can connect to the shared memory, but anytime I read from it or write to it, it's incrementing along its shared memory. It's going to the next character and the next character. But it's not a stream, it's shared memory. So I need to get back to the beginning. So what I have to do is I have to connect to it. That gets me at the beginning, and then I can read the status. And then I have to disconnect from it. And now I can check the status. And if that fails, I loop back around. So this is really like not optimal. But let's say it does succeed. Now I do the same thing to the data, and I get the number out of the data. And now I can, or sorry, I'm writing to it. I'm printing using printf. I'm setting data, then I'm setting the lock, and each time I'm connecting to it and then disconnecting. And once I've done that, I go into a different loop where I'm now waiting for the response. So I'm going to have to keep connecting to the lock and checking. If it's not, I'm going to skip this until it is true, and then I'm getting the data back and setting the lock. And that's just this function. These are kind of the back-end things. Here's the test where I've kind of made it generic, where this test now can use all 4 different backends here. So all it's really doing is this little thing is basically saying you need to choose one of the options, a client, shared, socket, or pipe. And client and shared are both using shared memory, but client is spinning up that little tiny helper binary. And this is, I'm saying right here, I'm saying 100,000. This should be 1 million. The numbers I was telling you about earlier was based on 1 million. Actually, if we do it for 100,000, we'll see it's a little bit shorter. Yeah, let's do it 10,000. Because again, the client thing is so slow. But all it's doing here is we're doing a loop, and we're sending in whatever the iteration of the loop is. We're using that function that I defined. We're sending it in, and then this reply here is a global reply. So that reply it's in all of them. It's the fastest way to get an answer back because I don't want any subshells. I'm not an expert in Bash, but I'm trying to make Bash run as fast as possible. So I run this function call, but I don't get a return out of it, because if I wanted to return, it would look something like this. It would say reply equals, like this, right? And the problem with this is this is a subshell and this is slow, and I don't want to do that. So what I've done instead of this is this function is writing this reply directly. So if we go in here to shared, right here, it's reading and writing it to reply. And reply is just it's just a global variable, basically, I'm using. And that seems to be, a fast way to do things. So So this thing is just sending. This is getting the reply of that send. And this is I'm just incrementing total received. So I'm just incrementing this one. I thought I was testing. Oh yeah, I'm testing it. Sorry, I'm losing it. I'm checking to see if reply is the same as increment because I've set the increment number to the server and then sent it back again, and now I'm checking, is it actually this? I could have checked it even better, but this wasn't working for a very long time, and then it wasn't my different backends. One of them would be working and a different one wouldn't work. So I do know what it looks like when it doesn't work. So this again is just a toy program to see how fast communication happens. But anyway, I'm kind of checking it. I'm incrementing. If it fails, I'm bailing out. And at the end, I tell it, how much. So like right now, I think I set it to 10,000. Yeah. So I can run this. First, you would need to build it. So I say make, and you can go make clean, make, you can just say make, but we want things to happen fast. So make release uses O3 and some other stuff in the make file. And when you run the make file, it builds the server and the client both. So if I say make, say clean release, we don't need to do clean because it hasn't been built, but anyway. And you can kind of see the flags that I'm using. Yeah, there's O3, the native flag, some other stuff, because I do want things to run as fast as possible. So now what happens is this client, these backends, there's 4 backends. There's client, this client SH backend, pipe, shared, and socket. This thing is going to connect to one of those backends. Basically, it's going to source one of these, and these basically get the server online. So let's go look at the shared one again. The shared one is going to set some variables. It's going to make sure that the server has been compiled, or it's going to tell you to compile it if it hasn't been. It's going to touch the files so that they exist, this for the shared memory. And then it's going to set the lock to 1. The reason why I set it to 1 is because if it was 0, it would immediately try to send information, but I don't know if the server's up and running yet. So I set it to 1. The server, when it gets up and running, it's going to clear it. So basically, when it does hit 0, I know the server's up and running and I can go. So basically, I've preset it to 1, so it's kind of blocking. And I'm checking to make sure the server is actually running. Or sorry, I'm checking if it's running to shut it down, because on shared memory, it needs to be shut down first. It can't be already running from like a stale run before that, or something failed and didn't shut down. So I'm making sure it's not running. Now this is where I launch the server in shared mode for this backend. So the server's name is just server. It gets compiled to this binary server here. But there's 3 options in the server. There's pipe, socket, and shared. And I'm detaching it, and I'm getting the PID from it, so I can kill it or see if it's running. I'm making sure that it is running. And now I'm kind of I have 2 functions here. One's a cleanup function that's it's going to, if it's trapping just exit right now. So if I were to try to kill it, it would send a kill, which is a state 3 to the lock, which the server will pick that up and say, okay, it's time to shut down. And I'm also removing these files that we created above and exiting either 0 or 1, depending if it failed or not. And we've already seen this send server function. That's long on this one, but it's depending on the backend. So the client, we can choose the backend. So it'd be run test, and then we get to choose the backend. So if we do pipe on 10,000, it's going to be immediate, right? So it's already done. Let's time it. And it says it took 200 milliseconds. So we do socket. It took 400 milliseconds, which tracks it takes twice as long for the socket. For the shared, it's going to be a bit slower. It's 1.15. This is just for 10,000, not 1 million, but I did test it for 1 million. And client, probably going to take like 15 seconds or something like that, because it takes about 15 minutes if it's at 1 million. And it's going to finish. It took me a very long time to figure the shared memory out. That was the hardest one. So 13 seconds, it says here. So, it depends on what you're doing, how things can vary. So, like I said, this is just for people who are kind of wondering. And I tried to put a lot of even oversimplified comments in place just because I went down this rabbit hole with this thing. I started working on this thing about shell to SDL for no reason, and then I started going with this, like, what are all the ways? Can I implement all the ways, and which one is faster? I'm just going to make sure this stuff is running, and it looks good. Okay. So yeah, so let's see something more interesting than this, because this is nerdy cool, but this is not what I came here for. So let's look at ShellGame. So this is what I was doing all this research for, because basically I implemented that same type of thing here. So we have client, we have old pipe doesn't mean anything, pipe, shared socket, and then we have this text test and yellow snow. So I kind of started working on yellow snow, and then I got sidetracked, and I started doing this text thing to see how much I could push it, and then I went down this rabbit hole of the pipes. So see. So this is kind of just a beginning phase of the Don't Eat the Yellow Snow. I haven't implemented sound yet, and I'm going to do a couple other things, but basically this is all the logic. So a lot of this stuff is kind of unnecessary, but all the logic of what you'll see is done in Bash. The logic's happening in Bash. The game loop is happening in Bash. There's no cheating here. But the actual memory management is happening in C. So if you tell something to move, you're telling it to move from Bash. If you're checking collisions, you're checking it in Bash, all that stuff. But like actually drawing an image to the thing is happening on a C server. So let's see if our make thing works. Hopefully that was already built. I have no idea. So let's go pipe. Okay. This isn't the full game. I'm just messing about, but let's run the so I'm getting like 700. And so I just wanted to see text, because basically that text, that's not such an easy thing to do. I have to tell that text not just to move around, but to keep drawing and stuff, right? This kind of took me down this this kind of hole of, like finding stuff out. And the keys and everything are happening in Bash as well. So I kind of went this route of this is the dumb implementation. And this number down here, it says I'm getting 2,000 frames a second. So this thing's running at 2,000 FPS right now. It's being hopefully sent to you at 60 frames a second. I'm not sure if it's working or not. But on my system, I'm seeing the screen at 120 frames a second. But this thing is running at 2,000 right now. While it's paused, when I run it, it'll probably be 700, because it's doing bounds checking. It's colliding with the snowflakes, and I'm doing all of these